Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science, just like I did. Today we're doing another example from the LeetCode series, specifically reverse linked list. As you can guess, it's about linked lists, and it's in the easy category. But also keeping in mind, it's a pretty useful thing to just be familiar with because it comes and sneaks into other problem sets. So what is the problem? I think it's fairly intuitive. You're given a linked list as the input. They're going to give you a head pointer. So, I like calling them pointers because that's how I think about them. It points at the beginning, and really when you do like a head dot next, you're kind of just moving to the next element, in this case 2. And basically you return the opposite way. So the approach that I am proposing is the following. There's many ways of doing this. There's even like a recursive approach. The one that I find simplistic and somewhat intuitive is basically the one where we are saying, if I start with a none, which I like to write as a little 0 dashed or crossed out, then kind of an idea is if I'm going through this way, right, then let's just pull that right next to this null thing. So that's what I'm figuring out the first time, right? And then I go to the next one, and that's going to be the 2. And so ultimately you kind of fill it this way, but because the arrows are pointing in this direction, you are now ending up at the end, if you read it this way, with the sorted linked list. So that's really the key over here. So how do we go about it? I'm doing it a little bit in a lengthy way here, and I'll show you like a solution example that is a little bit cleaner. But you know what? For what it is, I think it's it's a teeny bit more explicit, so it's fine, in my opinion. So here are a couple of things, and they actually even give us hints of them. I believe not in the examples that we're seeing within the problem statement, but further on when you play around with the problem. And that's thinking about these examples, like key examples slash, edge cases, is things like just given an empty linked list and say, for example, one that just has one value in it. So that's what this is trying to basically serve. So how is it going about it? Well, we go in and it's just saying, well, actually, technically, if the head was a none, or even if the next one was a none, i.e. it just had one value, but then the next thing is a none, then you can go ahead and just return the head. So that takes care of this part, right? Now we get to the actual meat. I like this kind of cleaner in my head approach of just saying, you know what, this none thing that I talked about, that's going to be the whole key of connecting factors, I just want it to be its own thing. Now, realistically, you kind of don't want to have an actual sort of like a none node, like one that literally has like a none or something. So you could just start right away over here. And what that means is instead, I am just giving it actually directly the head value, and that's what I'm calling my sort of first element in this reversed, REV for reversed, linked list. So that's ready, right? So now I have this sort of one that's just waiting to do stuff. And the idea then is, all right, we're actually done dealing with this one. So, so we can kind of cross it out and we move to the next element. So that's really what then this part is doing. And now the second kind of meaty part is while I haven't reached this part, because this is really when the element itself would be a none, because the last thing we always have is a none in the linked list, at least as per also the definition. So there, while we're still in the meat, here I say we have not reached the end of the linked list, then what we do is we save this, similarly to the above, we save that value that in this case, for example, is the 2. And then the trick is to say, actually, the 2 that you just saved, can you tell its next to point to what I've been calling the reversed linked list? So this guy only acts as a temporary piece where it grabs the thing you're interested in, but really the key is sort of in that reverse. All right, and then you say, okay, and then when you're done, because the beauty of it is you always want your reverse to be sort of this finalized. You're walking towards giving it as the ultimate thing that's being returned. So if you look at it, right, what you just ended up with here is this. The thing that we were talking about is a 2 that's pointing to a 1. Like, doesn't that look like something that's starting to reverse the flow of the input? So that's exactly what we're doing. And basically, we kind of continue doing it. So what happens in this other next step? Then we say, yeah, please do go ahead and grab this nicely, pretty kind of snake structure that's being created, this linked list. And then, of course, because at the end of the day, we are looping, so you just want to make sure to say, all right, we've seen now this part, so moving on to yet the next thing in terms of the head. And you sort of continue doing that until you end up with the 5th element and the other ones are linked properly. So that's pretty much it. Really, that's what this one is doing. And then I promised I'll show one that we could do a quick. I had a couple of typos the first time, but well, at least we see that one, and then here we go. Oh, the funny thing here is sometimes the results are drastically different. Like it went from 6 to 61, and earlier it was 70, and so just keep that in mind with LeetCode sometimes. So I think this one was interesting with the solution, which is unlocked, I think, for everybody, is you kind of don't necessarily need to have this because it's kind of happens by itself. So this is just a little bit cleaner, in my opinion, in terms of, if you wanted less lines of codes, but not that big of a difference. So, yeah, so in this case, for example, if your head was null, then you'll anyways be returning null like that. That's sort of what I mean in here. Therefore, we could also reduce it if we'd like to, but we'll leave it at that. So thanks, everybody. If there's any questions or comments or specific problems you'd like us to look together at, I'll also try to get us started on sort of more theoretical and more data science specific topics. So looking for suggestions there. And if this is interesting, please subscribe. And until next time, bye-bye.